Welcome. So, welcome, guys. We're going to be starting by in 4 minutes or thereabout. Just give room for other persons to join in. Fellow Jitster, I must admit your dedication to these sessions is very wonderful, extremely wonderful. So yesterday, I do remember your name from yesterday, and today as well. That's wonderful. Okay, guys, it's 2 p.m. I don't know if we're going to start now. We're just three here. Please, Adele and Matt Shidiso, you can unmute your mic and talk to me if you
Yes,
are
hi.
able to
You can
talk.
call me Matt. It's okay.
What did you say?
You can just call me Matt. It's fine.
Okay, okay, Matt. You're South African, yeah?
Yeah.
Yes. I recognize that accent from anywhere. I can't recognize it from anywhere now. So I don't know, the person holding the session on the Slack hold has not ended his. So I think some people will join us later. But for now, I think I should just start. Two persons. Adele, are you there? Adele, lovely name. me increase the size. Is this size okay?
Yep.
All right. Let me just pin the screen to the. Okay, so today I wanted to talk about actually printing to standard output because you're not allowed to use any standard library function. So no put char, no put car, no put s, no put s. The fs is just for string. So normally you use put car to print your characters and use put s to print strings. So um, both functions, I don't think you need to create a new function for put s because put s will just basically call put car to print the string, whatever string you pass to each character by character. But I thought of a better solution would be to print these characters in a more optimized way without calling write so many times. Because we think about it, when you have a string, and let's say the string is 20 characters long, and you want to print all of that to standard output, you have to call write 20 times because write only takes in one character and writes it to standard output. So you have to call write 20 times, and that's not very effective. So today we are going to be creating those functions. I really don't, we were not allowed to do something like this, but I don't think this is part of anything special at all, right? So you've already had the opportunity to create your putchar function, or putchar was even given in the beginning of C. So we're just going to go through it, how that function works, how to create our own, because we're not going to be using the standard library. So we're going to be creating our own now, the put card and the put card and the put s, and then an optimized version of the put card. We're going to optimize the put card. And after that, we am going to open the floor to everybody in case you are already working on a printf project and there's somewhere that you are, stuck. You can share your screen and we get to look at it together. And maybe I teach you how to use or effectively use GPT. It's a really cool software if you know how to use it. If you don't know how to use it, you may not be learning from it, right? You might just be copying the code that it provides and testing. But you can actually use it to study, especially when you're not like reading up a concept. You're now actually programming. So let's get into it. So I think the first thing we should create here is the let's put car. And this is how we're going to call it underscore putka, and then we're going to call the other one underscore put s as well. I'm going to also show you some cool stuff to do in Vim. I don't know if you guys still use um what's it called? The sandbox. Sandbox is very slow. It is not recommended. If you have not installed Vagrant, I recommend that you do install Vagrant, unless you're not doing this program with your computer. Or if you're doing it to your phone, you may not be able to install Vagrant. But if you're doing it with a computer, whether it's a Mac OS or a Windows OS, you can always install Vagrant. It's very cool, it's very fast, it's way better. And everything you have here, and another important thing that people don't understand with having your own personal virtual machine is that when you're done with this program, ALX sandboxes are going to be destroyed. You will not have them forever. So most of the stuff you would have worked with, like say GCC or Python or Node, like you're going to be working with so many stuff, Flask, so many frameworks, and all of them are going to be normally installed on the sandbox, and you will not have all of them anymore. But if you're using your Vagrants, you really, all of them will still be here. You can still work on them. You can still develop apps and whatever, and do whatever you want to want. you want to do with your virtual machine. So that's another important. I think the last one will be when you guys reach using working with servers. Using the sandbox will just give you so much problems, so much problems. But if you have a virtual machine or you're using a personal machine, it will release, it will free you a lot of stress. Okay, so I think we should also create a main.h because now I like I like putting all my includes inside the main.h rather than wait, what did I no I didn't put C here. Yeah, that counts. So in Vim, please someone should confirm they can hear me. I just want to be sure.
I hear you.
Yeah, we can hear you.
Okay, thank you. So a cool trick in Vim is you can actually open different tabs. I don't know if you guys know this. We don't need to go outside actually. So we call this in the H. This is a different tab, as you can see, and I don't have to like go outside. I can open as many files as I want in here without going out and coming in, going out and coming in. It's really stressful. But again, I don't think. Okay, yeah, it's the same thing whether you're using the sandbox or not. So I'm just going to what would be include guard and in here, like I said, I like defining my headers. No, that's not what I want to do. So rather than doing them on the respective files, I just do all of them here so that I only have to be doing, include main.h and every other header will be included. So you can do stdio.h. And also let's do standard live. I think we'll be using, and then for the right function, I want to talk about, we'll have to do unit standard. I think that's all. And for our prototypes, does somebody have something to say? We want to create the putCar and the putS functions. So putCar will take just a character, and they both return integers. PutCar will return just one because it's writing only one to the standard output. While putS will return the total number of the string it has written to standard output. So they're still returning, both of them are returning integers. So putS will take a string and say str. Oh, is there anything else that needs to be here? We're just doing something simple today. Okay, Adele, you have something to say?
I'm sorry, man. Can you hear me now?
Okay, yeah, I can hear you.
Yeah, I just missed the first minutes of the session. So I just want to know what you will do in the session. Like you are going through forward the code itself of the whole printf project.
No. We are not allowed to go through the whole printf project. You're supposed to do that yourself. So what I did was I thought write functions is very paramount. Like no matter what you are going to be writing, you are going to be printing them to standard output. So and you're going to be using custom functions like underscore put car or underscore put s. Like you're going to write those, right? So and again, I think both of them have been, I think if there were projects to write these two or something like that. So just tasks, not even projects, just tasks.
Yeah, we did it before.
Exactly. So I wanted to show you okay, some persons who may not be able to do it. And then I want to show you an optimized version of doing this, and I'll show you why it is optimized as well, of using the optimized version of the putcar. Yes, I'm not just
Yeah.
calling write so many times. And after that,
Thank
in
you.
case you are stuck, anybody who is stuck anywhere in the printer project, we can look at it together. I can show you how to get solutions and solve whatever problem. That's if you've started the project.
Oh, okay. Okay. Thank you.
And then also showing you some cool tricks on using Vim, which is very cool. If you use Emacs, also a cool one. I don't use Emacs. I don't really know much about Emacs. I just
I'm
custom.
fine with them.
Okay, so let's create another tab. Call this one put S. We have the put car, so we also have put S. And my mouse also works inside my Vim. Cool. To do, if you want your mouse, if you use Vim and you want your mouse to work, you just, this is all you have to type. Set mouse equal to, if you see the bottom of my screen here, set mouse equal to A, which is for all, and you'll be able to use your mouse. It's that simple. If you don't want to keep using the buttons, it can be very tiring. You can just scroll your mouse. All right, so let's continue with our putcar. Putcar is actually the easiest one. They're all the same thing anyway. So we already have our putcar, and then character it takes. In JavaScript, you have to put those curly braces immediately after the closing parenthesis. There is a C. Oh, and I'm not writing comments. Please pardon me so that I don't waste too much time doing that. There will be no commenting since this was a test. Good. Something. So in putcar, normally we just want to write one thing to standard outputs. No, we're not doing much. And we're calling write. The function we use here is write. And the write takes 3 arguments. One is where you want to print it to. So one normally represents standard outputs. There's 1, 0, and 2, I think. 1 is standard output, 2 is standard input, and 0 is standard error, if I'm not mistaken. No. I think 0 is standard input, and 2 is standard error, but one of them is standard error. And then the second argument will be the character you want to print, so address of the character. And the last one is the numbers of characters you want to print using write. So in this our case, we're printing just one character, so also 1. And that's all. And since we're doing int, this will have to return 1, since we're returning just one character. So, pretty easy stuff. And here too, we're going to first of all include I missed this .c again. Don't worry, I'll just write it like this, and I'm going to edit it when we go out of here. I'm going to rename it right. So again, there's no formatting, sorry. Put S takes a string. Shit. Nah, can't do this. I'm sorry. Give me a minute to rename this file. The formatting is just wrong. Okay, now we have correct formatting. Good. So for put S now, we want to call put char inside here, because whatever string we get from here, we want to take it from here and send it to putcar for us so that putcar prints it character by character. So we're going to be using a for loop, obviously. Or any loop for that matter. It can be a for loop or a while loop. I think that's all the loops for C. Oh, there's do while loop. That's not what we need here. Where were we? Declare variables, say I equals 0. Please, if you see any error, you can definitely mention it, or any place of correction. So int I equal to C, for loop, think equals to C. I equals 0. No, no. I'm going to use a while loop. Oh, and then let's change this to SR because that's what's in our main.h. So y_str of I is not equal to null. You don't need to write that. It's the same thing because while loop checks for truth values. So if this has not hit a null character, it's always going to be true. So you don't have to write not equal to null. It's not necessary. We want to put car. I want to call put car here now and pass in our str of I. Right. So in your function, when you're building your printf, you have to put these two functions inside inside one file and name it whatever I want. Maybe name it write functions. They'll just be there and they'll be called in several places on your from other files when you want to actually print standard output. So we put char str of I, yes. And this function also returns. It's not actually what? Yeah, it just returns 1 since it's calling put char. All right, so to test this, we have to create a main.c. Our main.c should have okay. So now we're testing putcar. And we just pass in a character here, say S. And we also want to test our put S. And for this, we pass in a string. Should we create a string that? Oh. So, yep, if all things are right, this should not. Okay, no. Since we're returning an integer. Oh yeah, I see a mistake here. Semicolons are necessary for C. Okay. Hello? Somebody wants to say something? Whose mic is not muted? I can't really tell. Okay. So we have GCC, and I'm using GCC, but if I use GC to use, and it's actually a style. So if I do alias, you can see GC here as it's an alias for GCC with all the flags that ALX uses. So rather than doing GCC and plenty stuff, you don't have to do that. And if you want to make a file executable, it's also an alias, just EX, and it does the mode for you. There's also different aliases for different Python and JavaScript. That's not why we're here. So I'm just going to use GCC just in case. I don't want all those wall and where to give me any errors. I'm going to call all the C files. Oh, I compiled nicely. So segmentation fault. Okay. Let's see. One of our files is not working very well. That's not a problem. Okay, so it prints. I think we're printing S first. So yeah, it prints the S, and then but it fails in the put S. So I observe I is not equal to null. Whoa, I'm sorry. While loop has to take in plus plus. And because we're not using for loop, we can initialize it to 0. Do this again. Yes, so it prints the S, and then this is a test string. No need for any new line or anything. Let's just correct that. So after it prints the S, let us just print F. New line down. And also after the string, let's print. Okay, so yeah, so now it works. This is the default. This is the default put scan puts s put string function. So now how are we going to update it? How are we going to optimize it rather? So for the optimization, we're going to just be working with the put card because that's what we want to optimize because the put s calls the put card, so we don't have to do anything there. So here is where we want to optimize. So normally, like I said before, if you want to print a string that has 50 characters, for instance, you have to call write 50 times. So what about you want to print something with 1,000 lines, 1,000 characters in a string? You have to call write 1,000 times, and that will take a toll on your program. It will be slow, basically. C is not slow. You may not even notice it, but well, that's why we do optimization. So to optimize here now, we need to create a buffer, right? So instead of calling write every time, we'll create a buffer. So a buffer will be our buffer will be an array that these characters that we want to save or want to print out would first of all be saved into the buffer, and then when we are done saving into the when we are done with the entire string, we now print everything from the buffer, right? So that's just what we're going to do, and then we'll go from there. Okay, so first thing first, we create our buffer, right? So just call it buff here, and we'll say 1,000. You don't want this buffer to be too large. Again, if it's too large, you defeat the purpose because it's going to take because arrays take contiguous memory in space in memory. So it's going to reserve too much memory. If you put like 10,000 there, that's you are reserving too many integer character space. So let's just use 1,024. That was be our standard. And now we're going to be we're going to be saving to the buffer, right? So let's come down here. Before we call write, we'll say, oh, and then again, we will need a way to tell the program that it is time to print or to print everything into standard output. So the way I came up with was, if it's we're going to call put char with a -1 with -1. Every time we call put char with -1, we're basically telling put char to put car. I always say put car or put char. We're basically telling put car to print everything that we have in the buffer. So if it's not -1, then we want to save into the buffer. But if it's -1, we want to print everything inside the buffer. So we'll just say if our character that is coming in is not equal to -1, right? So we want to say our buffer. Yeah, we have to create. Hi. Okay, first of all, I'm going to do it like this and then tell you why we cannot do it like this later on. I just remembered something. We're going to create our buffer, and inside where I would be, we want to save the character. So we don't want to print it yet. We just save it inside where I will be, and then we increment I so that the next character that comes is saved, after the first one, like that. And then before we print, so if it's not, this is when it's not equal to 1. So if it now becomes equal to 1, so if C is equal to -1 rather. If C is equal to -1, that's when we want to call right. Let me just copy it, delete it, and paste it here. C is equal to -1. We want to call right. And yeah, there's another thing we have to add here, because it's not just when C is equal to -1. What if the buffer is filled up? So our buffer is just 1024 characters. So what if the buffer has 1025 characters? What's going to happen? Our buffer is full. We'll now be writing, we'll just get called segmentation fault, because we'll be writing to memory that we have not saved, or memory that we did not reserve. So we want to also check if the buffer is greater than or equal to the amount of memory that we have reserved, so that it also prints when it gets to the end. That's if we're printing a string that is beyond 1024, and we are going to be doing that. So once we do that, once we write, we don't want I to still be whatever number it is. And again, this is where I want to tell you now that, you see, when you create a variable like int I equals to 0 inside a function, whenever this function is called, this integer is going to be initialized. This I is going to be initialized to 0. So for instance, if we're calling put car from our put s, for instance, and when put s comes here, it will always initialize this to 0. So we're going to just be printing the first character over and over again to just be an infinite loop, because I is always going to be 0. Then that's not what we want. So how do we make this how do we make I to last throughout the lifetime of, to hold its value throughout the lifetime of the program, not just when you call the function? In other languages like Python, you just have to declare I up here or somewhere else and then import it here, and it will hold its value. But in C, we can use something called static. So by adding static in front, we have just made I to hold its value throughout the lifetime of the program. And again, another thing is, when you use static keyword, any variable you declare inside the function with a static keyword is auto initialized to 0. So you don't have to like int I equal to 0. Plus, in this our case that we want I to hold its value, it makes sense not to do that, because every time this function starts, it might want to initialize I to 0. And again, our buffer would be, we don't want a new one. We want that previous one, because if we do this, if we lose the pointer to this, because here we're just calling buff, and if we don't tell the program that we want this buff to be the same one, it's going to create another one somewhere in memory, and it will not be printing what we want. So for the same reason, we're adding static to that. And then now we can now initialize after we print. We cannot say I is equal to 0, because we want to start again. So if we've gotten to I, we want to tell I will always retain its value. So the only way to make I come back to 0 is inside this function. We'll call it like, okay, I be 0, so that next time we call put car, you will start from beginning. So every time you print, reinitialize I to 0 again. So this is like an updated version. Let me look for errors. Yep, so we're not printing C directly anymore. We are printing the buffer. Also, we're not just printing one character, we want to print the ith number of characters. So if I had been accumulating, say, 50 characters, we want to go into the buffer and print the 50, because those 50 characters will be there, right? So, and with this now, we're calling write once every 1024 characters. So if you are printing a string of less of 1024 characters, write is called once. Meanwhile, with the other version, if you want to print a string that has 1024 characters, write will be called 1024 times. That's not very effective. It will make your program slow. So Yeah, I think there's no error here. So if we actually run this, it will not give us any. If we just run our, if somebody wants to say something, Adele again. Do you want to say something?
Hello. Yeah, I'm sorry. Like, why are you comparing C to -1? Like, are you checking if it's out of memory?
No, we're actually going to be calling putscar with -1 whenever we are done. For this our updated version, right?
I'm
So
sorry,
whenever
just to talk slowly. I'm sorry because I just don't get it. Please.
okay. I'll
Yeah,
I'll
I'm
go over
sorry.
it. I also made a mistake here by not putting I. So not or if I is greater than or equal to 24. So let's just say let me just okay, I'll use it. This is not part of the code. I'll delete this afterwards. So let's say we want to call this putscar now, right? If we call it if we call putscar or maybe uh, you know what, our putscar now can even print strings. From what we have just known on our putscar prints a character because it's taking just one character. We have to use puts s to call it several times because put s does the loop thing. So let's say we want to print this is a test. Now, when you call put s in our put s, let me just open that file so that we can see it as well. You know. So in our put s, when we pass in the string, you see our put s goes through the entire string until you hit null and prints and calls putscar with the characters. So if this, for example, here it has several characters. So when it finds t, it will pass in the t to putscar for putscar to print it. It will go to the next character and it pass in h and just like that. And then when putscar gets it here, right? Every time now that we're calling putscar will just check is c equal to -1. It's not. The first thing there is t. So it will skip this whole thing here and come down here. Say if it's not equal to minus, we don't have to use this if statement anymore because it will first of all to check this. Once it doesn't check this, it can run this code. So we don't even have to do this. So we now do if c is equal to -1, we now check if c is equal to it if c is not equal to -1 rather, and then we now write that character, the t that it has passed to us, into the buffer that we've created, and we increment I, which holds its value. So when we pass h to putscar, the buffer has t inside because the buffer is static. It doesn't change. I is also static, so I's value is now 1. So it will check if it's -1, it is not. It will come down here and write the h into wherever the I is pointing in the buffer. So I is 1 now. So this buff the second elements there inside the array to write whatever character was passed, which is h. So it writes h into the buffer and then to increment I and then keep doing that until it reaches the end. So when it reaches the end now, it's now your duty because now there's no null. We're not checking. It's not going to call null basically. If not, so now, for example, here after after this, we have to now call putscar to tell putscar that okay, you can now print, right? So we just do -1. So when we call putscar with -1, after giving it all of this string, it will now come here and check if putscar is equal to -1. Be like, yeah, I'm equal to -1 now. So I can now go in there and use write once and print whatever is in that buffer, I number of times. Initialize I to 0 and we're done. So this is how we're going to use it in our main function, which I'm going to show you now. Okay, so now if we go into our main function, before here we're doing putscar one character. So if we wanted to print after this character, we can actually now leave all of this. We can actually call just once. It will print the S, or it will print S and then this is a string. but we have to come under after everything and now say let's do an underscore. Now call putzka with -1. So if we run this, it should print everything. Okay. Yes. So he prints a new line somewhere here. I don't know why. So he prints the S and then prints everything. Let me see why it does that. Oh, okay. Yeah, there's a new line here being printed. If we delete this, clear this screen. See now it prints the S and this is the string. So now this is how, I'll now show you an example of, okay, for example, now we've written all of this. We don't know if all of this works, right? We don't know if it's faster than the main putka. So we have to check it. And for that, I have a file that we can use to test. I think it's called input.txt. So I'm not going to cut the file here because I'm just going to show you how many lines that file contains. So you can see that the file contains 10,000 lines. It was a file that was given to us to do some pagination with in Python. The actual file contained 19,000 lines, but I put only 10,000 into this file just for testing. So this file contains 10,000 lines. So normally if you call putzka with this file to print the entire content of this file, it's going to call the write function 10,000 times, not even a joke. And that's not great. We want it to call, okay, now for our buffer that is 1,024 rather, it's going to call writes only 10 times because 1,024 times 10 is it's like 10,240. All right, so that's how it's going to call writes 10 times. It's like calling writes for the same amount of time that it will call to print 10 characters. So we'll test it and see which is faster. So if our new putzka is faster, we know that we've done some optimization. Otherwise, we've wasted our time. So let's just go into the main.c again and update it now to hold. I'm just going to include something else here because we want to check the time. So there's a library called time.h that you can use to, check time stuff from your program. I can use the mouse, but I'm still so used to using the arrow keys. It's weird. Okay, so first now I want to create some variables, start and end. So the start time and the end time that what we're going to call is going to take. And the library has something called clock_t. You should have seen this where we like ALX like doing things like list_t from things like this. So there's clock_t, which is a type now from the time.h library to use with, just like when you do type def and then you name your structure list_t. So if you want to create a variable of that type of that structure, you now use list_t and the name of the structure and then whatever you want to the variable name. So now we're using just clock and then we're doing start and end. We're creating two variables, start and end, that we'll use for, and then we want to also create an execution time. The time will be we want it to be in floats, not integer, because if it's integer, we may not see the difference because C runs very fast. So an execution time, and okay, let's just go down a bit. So come down here. So now I want to open that file, right? The inputs.txt that we have in our directory. We want to open it, get all of whatever is inside there, and give to putzka to print to standard all the 10,000 lines, character by character. It has to print it. And it's not 10,000 characters that actually. Is it 10,000 characters? No, it's not 10,000 characters that are inside that file. It's 10,000 lines. each line contains like its own number of characters, maybe like 30 or so. So it's 30 times 10,000. So that's a lot of characters, and that's a lot of times to call write normally. So we're definitely going to see a difference. Definitely. Anyways, what do we have here? I think, yeah, file. So we use fopen. Fopen is way better than using just open. Open is a little bit more stressful. But I think fopen is the newer version. So we call fopen, and then the file it takes two arguments. The file wants to open and the permission that we're giving it. So we're giving it the read permission to read from the file. And just for checking sake, we have to always check, just like when you create malloc. When you reserve memory with malloc, you want to check if it actually reserved the memory by checking if it's null. So if you return null, you want to end your program, because if it returns null, that means it was not able to save, to reserve the space using malloc, and you want to end your program. Otherwise, if you allow that program to run, it's going to crash because there's going to be a lot of garbage value that you'll be trying to access. So I'm just going to do if our file is equal to null, it's another way to print to standard output, but this is not printing. This is printing to standard error, not standard output. Let's just say error. What is this? Or okay, error. And we want to return. We don't want to continue from here because our program has inadvertently failed. But if everything went well, we want to, okay, now, yeah, we want to use a while loop to print this entire file. So how do we get characters from a file? We'll use a function called fgetC. It's a get function that gets one character every time you call it from whatever descriptor you pass to it. So we're going to say C. We can't just say fgetC. So we're saving fgetC in something like ch. We do fgetC, we pass the descriptor file, and we say if it's not equal to, now it's not null. You can't say null. No. You have to say, because now the file descriptor it's a file, so file comes with something called EOF, which means end of file. So once we get to the end of the file, we stop this while loop, basically. That's what we're doing here. We have not declared ch. Just go back up here and do ch. So when ch reaches end of file, we stop. We don't have to put curly braces because we just want one line here. And first, I know, let's call putscar first. So this is the normal standard library function, putscar. And we pass in ch to it. So putscar is going to go through the stress of printing these thousands of lines. And just like I said before, once you are done with that buffer, you want to call -1 so that it knows that it's going to print, and then it starts again. So this is the main thing that we want to print, right? This while loop is what we want to do. So we want to check the start time and the end time of when this thing will be over. That's the basic idea. So we can say our start that we've declared before is equal to clock. This is all. So this is how we call the clock function. This is not my The clock function is from our time.h. So we just call clock. So clock now, when you call clock without any argument, it saves the current time into start. And if, of course, after we end here, we want to get the end time. Let me just do spaces. So we want to get the end and call, clock again. So we get the time that this function, this whole thing here, finished running. All of this has finished running. So when we get those times, the next thing we want to do is to close this file descriptor. And then we can now print our execution time. I think we're done with the file here. Yeah, so we can do fclose. You don't want to close the file when you're done with it. If you close it, it's not going to be able to read from the file anymore. If you close it before you're done, it's not going to be able to read from the file. So we do fclose, and we can now do our execution time. Sorry, is equal to end, the end time and as the start time, divided by something called clocks per second from, again, the time.h. The clock per second is the time it takes for 1 second to tick. So the start time minus the end time divided by the clock per second to give us the total time in seconds as a float. And these guys are not floats, so let us typecast them. End and start are not floats. You see, their type is clock T. So if we do it like that, we might be getting just zeros. So typecast them to floats. Yeah, we don't typecast like this. We typecast like this. Okay. There's a semicolon. Okay, there's a semicolon there. And I think that's all. We don't have to print these guys anymore. We don't want this S. We don't want the puts. We don't want the. Do we even want this? I don't think we need this because at the end of every line, you have a new line. So it's going to print it as well. At the end of every file, rather. You have a new line, so it's going to print a new line as well. Okay, so remember that we're calling. Yes, if we are calling the normal put car, we also don't need to call this -1 because we're not using our own function. So let's go and see how many seconds it will take put car normally to print this. Okay. Yep. So if we do ./a, whoa. That is not good. That is not good at all. Let's check our main file. So we're getting input.txt. It's input.txt because if it's not, it's going to fail here. And is it here? Yes, it is here. Yes. So you can see that we are opening. We want to, what are we doing here? Yes, we want to put this inside. Yeah. I get it now. F get C file. We want to put all of this inside because we are checking if ch is not equal to end of file. But that's not what we have here. Right now we have ch equal to this, not equal to this. So that's confusing for the compiler. So we just bracket all of this together. And we should get /a. Okay. It has printed the entire file. Where is the time? Oh, we didn't call printf. we didn't actually print it. So we ended up printing the entire file without printing execution time. So sorry. Let's printf. Let's just put a new line here. Say execution time. It's %f and it's a float seconds. And we put another new line here and say print our execution time. Okay. Let's try again. This is a problem. Oh, there's no T. printf. Right. Okay, so it took 0.185 seconds. So it took put car. Let's just do that again. It's taking put car 0.2 seconds, basically. 0.2 seconds. Let's do that. The last time, there were about 0.2 seconds. So if we use our our own put car now, is underscore put car. Here, as I'm using underscore put car, I'm also calling put car -1. And if we compile again, do that slash a. Oh no. This is worse. Okay, now it's getting somewhere. So we're getting zero. Maybe I didn't see that first one actually. And we're getting 0.0. That was my confusion. The other one we're getting 0.2. Here we're getting 0.06. Right. So it's not like a very big difference. But the optimization there is that this 0. I don't even know how 0.0 something will be, but as in the difference between 0.0 and 0.1. But like it's printing it in half the time. Here it's 0.06, while the other was 0.0. What? Sorry, 0.2. This is 0.06. That's half the time. So that's how to optimize our putka by using. Let's just look at it one more time. By using a buffer and calling write once every 1024 characters. So yes, please, we have very few minutes here. What I want now is for you to show me your code. This is only the second day in the pretest project. I don't think anybody would have been coding, but you can show me something, and we can actually work on it. We can look at your screen and work on it.
Hi, Martin, sir. I haven't really started anything, but if it's possible, if maybe nobody has a question, could you like just go through the what you call the code again, the one that where you optimize the puchka, like just
Okay.
to go through it real quick.
All right. Okay. So normal putka, right? The normal putka, even the one that the real standard library putka, it just has. I'm not even sure. I don't even know if it's possible to see the code that is written in putka. Right? I'm not sure. Let's just see. Okay. I don't think they will write the code. That's just my see. There's no code. We're down to the end. There's really no code. It doesn't show, but I think they just call writes to stream. It's
Yeah, I mean that's okay. I actually meant the one that you just wrote, like
yes,
just to
yes,
kind of
yes.
like
I
explain
was
it
I'm
again.
meant to
Yeah.
show you that. I just wanted to make sure that the standard library one. So you mean the standard library one or the
Okay.
one that you use normally will just have the write, and then to write one character. So if you pass in those thousands of characters that I passed in there, it will take a longer time. It's just because C is very fast. If you give that to Python, it's going to print it in like 4 seconds because that's a lot of characters. C uses like low level memory, so it does that all very fast. So then that's the normal putka. No, but now here we are creating a buffer. A buffer is like a reserve memory. It's just an array here, but it's like a memory we are reserving, and we're making sure the memory stays all through the life of the program using the static keyword. So whenever you call putka in a normal function, if you come here, every time you enter this function, all of this will be resetted. There will be like if you return from this function, all of this will be destroyed. Any variable that have been created here will be destroyed. But if we're using the static keyword, it doesn't destroy those variables. It keeps them until the program ends, like the main program ends. So we're keeping this for the entire lifetime. So every time we get a character, right, instead of calling write for that particular character, we just write it to the buffer. Because what if there are more characters? It makes sense. What if there are more characters? We want to keep writing to this buffer and then just call write once. So we're not calling any function that prints to stream until we are done with what we want to print. So if it's in like if you're printing like little um, characters, you just get very small time. If you're printing like 10 characters or 50 characters, it will print them all once. It will call write just once because our buffer is 1024, right? So, but if it's more than, which is that file we used to check, if it's more than 1024, it will call write a lot of times. And but if you're using the normal putchar, it will call write once every single character, once for every single character. So if there are 10,000 characters, it will call write literally 10,000 times. But and I'm not sure that's how the normal putchar uses. Like if we rewrite this function and pass in, maybe we rewrite a double underscore, and pass to. I feel like testing that. We have like 2 minutes though, but it's just both of you that is here, so it's not like we're holding up this section too long. If we do like double underscore putchar and pass in C, and then write I think this will even help you understand better. And write only, let's just return one. Then we call write, standard output, one character, and so on. This is normal putchar, but now we're calling it underscore putchar. And let's just use this one. I really want to see the time because I'm feeling the normal standard library putchar would be like optimized a bit. That's why it's not giving us too much difference. But I just want to check. Let me just copy this guy here. What is that command again? We double underscore. And for main.c, we want to use double. And as well comment this guy out. So I don't know if this code is going to actually run. Yeah. Wait, what's that? Oh, Chelsea. Okay, you see? I see the difference. It takes 2.4 seconds if you use your normal putchar, the normal one that you know how to use. You can unmute your mic.
Yeah, okay. Yeah, I see.
Yes, you see now. So you see this to print this file took 2.5 seconds. You see that the main putchar, the actual putchar function is also a little optimized. Not that optimized as the one that we just did, but it's also optimized. Yes. So this is the normal one, and it's taking 2.4 seconds. But if we use ours, you see it takes like 0.06 seconds. So that's just the idea. So do you understand it? We just create a buffer.
Yeah, I get it.
Yes. We create a buffer. We write to the buffer rather than calling write so many times. And for every 1024 characters, we then call write, or whenever we pass in, -1. So this is an optimized version. It's even more optimized than the actual standard library putchar, which is very cool. So when you start building your your own printf, you just put in these two files. You just put in your putchar and your puts, rather than creating several files, because if you want to create them individually, you have to create files for putchar, puts, create files for how to print numbers, to print bytes, to print floats, to print several stuff. Because if you want to print
Mm.
number, you have to create a function for it. But that function is going to call either putchar or put. It's actually going to call put s, which calls putchar. Because you're going to turn all those numbers into characters so that you can print them. Because there's no way to know, actually. Anyway, so by using, I think, sprintf also. So you're going to put these two inside like a write function .c that you are going to be calling, basically. So that's it. You can just start somewhere. I say you start from, I called mine underscore printf. People call theirs different names. So you can just start from like underscore printf.c, which is going to be like the entry program for your
Mm.
entry for your program. Where you can now call like var starts, var all of them, var all of them. And that's from there is where you're going to be calling all the other several functions to do all the several stuff. But this is not the main entry. The main, you still have to create like a main and just put a test file there. So you can put main, you can create a main that calls underscore printf and tries to print something. So from the main, you will just do underscore printf. Like this printf.c would have an actual function. This underscore printf would have an actual like function. So, and you call this function from your um what's it called? From your main. And then it will now come to this underscore printf file and then run through them and do all the stuff that it needs to do.
Okay. Yeah. It sounds like, yeah. At least now I know where to start.
Yes, that's actually where you start. All right, thank you for attending. Since I don't
Thank
even know how
you.
to pronounce this guy's name. Sentamo Abel. So are you still with us or are you gone? Have you gone away? Let me just stop this live streaming. Actually, I want to do that from YouTube.
Oh, thank you very much for the lecture. It has really been so illustrious. We shall start from there.
Is that right? Thank you for attending. So, guys, that's the end of the session.
All right. Thanks, Martin.